Has this ever happened to you? You've memorized every single detail of an enzyme's catalytic mechanism. You can draw its active site in your sleep. But when you run the assay yourself, nothing. No activity, no signal, just frustration. Why? Because there's a massive, invisible gap between what you know on paper and what the molecule actually is in the tube. Today, I'll show you the exact framework to bridge that gap forever. In the next 10 minutes, I will give you a powerful lens to view your entire scientific journey. First, I'll decode the three-stage certainty ladder, from theoretical knowledge to existential understanding, and why most researchers get stuck on the first rung. Then, we'll make it brutally practical with real biochemistry examples you face daily, from failed PCRs to messy Western blots. Finally, I'll hand you a simple, actionable protocol to apply in your very next experiment to start climbing this ladder. By the end, you'll see your failed experiments not as setbacks, but as necessary steps toward genuine mastery. Your relationship with any biochemical concept exists in one of three stages. Stage 1. Ilm al Yaqeen, knowledge of certainty. This is textbook biochemistry. It's knowing the Michaelis-Menten equation, the schematic of the TCA cycle, or the primary sequence of P53 from a database. It's pure information. Example: you know that Mg2+ is a cofactor for polymerases. Stage 2. Ayn al Yaqeen, eye of certainty. This is hands-on, sensory biochemistry. It's the smell of V-mercaptethanol in the lab, the tactile feedback of a viscous genomic DNA prep on a glass rod, the sight of a perfect band on an SDS page gel you ran yourself. Example: you see your PCR fail when you forget the MgCl2 and you feel the problem. Stage 3. Haqq al Yaqeen, truth of certainty. This is intuitive, integrated biochemistry. It's when the knowledge is so internalized, you've become one with the system. You can troubleshoot and experiment instinctively, predict how a protein will behave from its sequence, or design a novel mutant with a clear mental model of its folding. Example: you intuitively know that adjusting the annealing temperature by 2 degrees will solve your primer-dimer problem without even needing to check a manual. Take a key concept from your work, e.g. Km. On a notepad, make 2 columns. What I know from papers, stage 1, and what I have felt in the lab, stage 2. The gap you see is your growth zone. Knowing these stages is good, but the million-dollar question is, how does moving from stage 2 to stage 3 turn a competent technician into a groundbreaking scientist? Let's apply the ladder to a technique we all love and hate: PCR. Stage 1, textbook. You know the 3 steps: denaturation, annealing, extension. Stage 2, sensory. You hear the thermocycler's blocks click. You see a faint smear on the gel and remember you were rushed during primer resuspension. You feel the disappointment of a negative control that isn't clean. Stage 3, intuitive. You look at a gel and think, smear, likely degraded template, or bad DNTPs. No product equals Mg2+ concentration or primer TM issue. Extra bands equals annealing temperature needs optimization. You don't just follow a protocol, you converse with the reaction. In your next PCR, don't just load the gel. At each step, ask, what is my sensory proof this worked? The pellet dissolved completely? The mix was ice cold? Document these observations. This path seems clear, but there's a sinister trap that keeps 80% of researchers on the lower rungs. What is it? believing that strict, mindless adherence to a written protocol is good science. It's not. It's stage 1 worship. It's the fear of deviating, of using your senses, of trusting the messy, empirical data from your own hands over the clean steps on the page. Get ready to get your hands dirty. In Lecture 2, we go from theory to tactile. We're taking DNA extraction out of the textbook. I'm going to show you how to read the quality of your DNA with your own senses. The texture of the pellet, the viscosity of the thread on a glass rod, the clarity of the eluate. You'll learn to diagnose your prep before it even hits the nanodrop. This is where knowing becomes doing, and doing starts to become understanding. Don't miss it.